So, what if you could turn a desert into a lush, thriving oasis? And what if you could do it with technology that sounds like it's straight out of a sci-fi movie? Well, today, we're diving into a system that's designed to do exactly that. A really high-tech way to take completely barren land and turn it into a self-sustaining ecosystem.
It all really boils down to this one question. I mean, just imagine taking land that everyone else considers worthless and transforming it into an engine for both environmental healing and economic growth. And get this, the research shows this isn't just some hypothetical idea. It's a real, practical model, and it's backed by some pretty solid data.
And the problem it's trying to solve is just immense. We're talking about huge, huge areas of what you could call sleeping land. It's degraded, sandy, all the nutrients are gone, and normal farming just can't work there. It's why so many aid projects fail, because they're trying to plant the wrong things in these incredibly harsh conditions. But this land has two things going for it, in a big way: tons of space and tons of sun. So the big question is, how do you wake up this sleeping land? Well, the solution is this fascinating concept called the self-producing oasis. It's called the CRISP system. And yeah, that's an acronym. It stands for Concentrated Radiation Intelligence System for Pioneer Plants. The whole idea is to kickstart this self-reinforcing cycle that doesn't waste water, doesn't need a bunch of imports, and doesn't burn diesel. The oasis, and I mean this literally, builds itself. All right, so let's pop the hood and see what makes this thing tick. We're going to break down the 6 key components that, according to all the research, make this entire system actually work. Everything, and I mean everything, starts with the right plant. This isn't just any old hemp. It's a super resilient pioneer variety. Its roots go deep. We're talking 2 to 3 meters down to find water that other plants just can't reach. And here's the magic part. It takes worthless land and not only makes it productive, but actually improves the soil every single year by building up new, healthy topsoil. Next up, the power source. But forget your standard solar panels. These things are way cooler. They're bifacial, which means they capture sunlight from above and the light that reflects off the ground below. But wait, it gets even better. There's a special infrared foil that actively cools the panels down, which is a huge deal in the desert, and it cleverly turns that extra heat directly into more electricity. How smart is that? And if you thought that was smart, check this out. Underneath the panels, there's another special UV foil that takes damaging ultraviolet light and basically converts it into the exact kind of light that plants love. At the same time, the soil gets a boost from this incredible network of mycorrhiza fungi. Think of it like a superhighway for nutrients that feeds the plant roots directly. The data shows it can increase yields by a whopping 23% during droughts. Okay, so what happens when the sun goes down? No sun, no power, right? Wrong. Using technology that was researched at Stanford, the system actually harvests energy from the temperature difference as the hot solar panels cool down in the night air. Now, it's not a ton of power, but it's more than enough to run the pumps, sensors, and lights 24/7, all without needing expensive batteries. That means it's completely energy independent. Of course, to protect this whole investment, you've got an AI-powered camera system called the Pioneer Eye Keeping Watch. It uses UV fluorescence to spot plant stress, from disease or pests, with over 99% accuracy. And it spots the problem a full week or two before any human eye could see something was wrong. So, no nasty surprises come harvest time. And here it is, the final piece of the puzzle that makes this whole thing a closed loop. The system uses its own electricity to pull nitrogen right out of the air and create its own green ammonia fertilizer right there on site. This is huge. It means no imports, no relying on crazy global prices. The oasis truly, truly feeds itself. So, okay, the technology is absolutely incredible. But what does all of this actually produce in the real world? Let's talk about the payoff, the actual financial and social returns that are projected.
So, the documents lay out a model for a single 10,000-hectare project, say somewhere in Ethiopia. After a few years to get set up, we're looking at the numbers for year 10 of operation. And they make a point of saying that these are conservative estimates. The real numbers could be even better. First, just look at the money from carbon capture alone. By selling CO2 certificates for all the carbon being stored in the soil and the plants, the project is projected to bring in 75 million euros. That's not a one-time thing. That's every single year. And what about the human impact? The jobs? The system is projected to create over 10,000 local jobs. And these aren't just farming jobs either.
We're talking about the whole shebang, from processing the hemp fiber and oil to managing the high-tech energy grid. But here's the metric that really blew me away. The project doesn't just sustain itself, it actually grows. The initial 10,000-hectare site is projected to revitalize a total of 20,000 hectares over 10 years. So it's effectively doubling its own regenerative footprint, making the entire area sustainably productive. There's a quote in the source material that just nails it perfectly. A project that captures CO2, reduces hunger, provides clean energy, and creates thousands of jobs on land that was previously considered worthless. That's not charity. That's a self-funding engine for transforming an entire region. And this whole strategy, it turns out, fits perfectly into a much, much larger vision that's already underway. You've probably heard of the Great Green Wall, right? This incredibly ambitious initiative to plant an 8,000-kilometer belt of trees right across Africa. Well, its biggest challenge is that the young trees often die in the droughts. The CRISP system is like the perfect partner. The pioneer hemp thrives in drought, it regenerates the soil super quickly, and it basically creates the perfect conditions for those trees to survive and thrive later on. And here's the crucial part. The money is already there. Of the $33 billion that have been pledged to the Great Green Wall, UN data shows that over half of it, that's more than $16.5 billion, is still available. Innovative projects like CRISP are prime candidates to get a piece of that funding. So the key takeaway here is that this isn't just some grand, far-off vision. The documents lay out clear, practical first steps. It starts small. You define a little 1 to 10 hectare pilot area. You apply for some small grants that are already available. You team up with local partners for things like seeds and solar installation. And, this is critical, you start registering and verifying your CO2 credits from day one to start bringing in revenue right away. And that really brings us to our final thought for today. The CRISP system, when you really look at it, challenges us to see the world's deserts and degraded lands in a totally new light. Not as problems that we have to manage, but as the largest untapped opportunity we have for regeneration. Maybe our definition of wasteland is just wrong. Maybe it's simply sleeping potential.